try the other way around. If y1n is periodic, the question is x of n periodic. Now we are doing what? The inverse. We are now doing the inverse. It says what? If I remove all these odd positions, compress them together, and it becomes periodic, does it mean before the operation it is periodic? That's what is your answer?
I think I said yes.
The answer is actually no. Okay, do you want to think about why this is not? The other way around is actually false.
Because there's some values, I guess, that are missing.
They are missing from this operation, right? Because you can see the operation says remove the odd positions completely, then place them together. After that, it's periodic. The question is, before that, is it periodic or not? Because now all the odd positions never show up in the final answer. Therefore, being periodic here doesn't imply periodic in the original signal.
So if you're going from that function to that function, you may get like at the odd integers, you may get values that could ruin the periodicity.
That's right.
Okay.
Because you can see these can be extremely high. After this operation still gives me the same. Because this from x to y1 completely ignores what happens in the odd position. You are right. This can ruin the periodicity of the original. Have I answered your question? Is everybody okay with the solution? Let's now look at y2. Okay. Again, the key of understanding this question is to really figure out what does this operation mean. What does this operation mean? Again, I'm giving you an arbitrary x. I'm giving you an arbitrary x. The question of you is to find out what is y2n. Is the question clear to everybody? This is some arbitrarily given x. The question is how do you find y2n? Is the question clear? Everybody clear about the question? Let's start from the beginning. What is y20?
What was that zero?
So I'm copying this part and placing here. Right? y20 is x0. How about y21?
Well,
Look at this, right? What is y21?
It's 0.
0. It's not nothing, it's 0. Right? It doesn't say nothing here, it says 0. So therefore, this is always going to be 0. What is y22?
Whatever is that? 1?
Whatever is at 1, I'm going to copy it. Place it at 2. How about y23? Will be 0 again, so this is 0. How about y24?
What is that? 2.
2. So I'm going to copy this. I'm going to place it here. And I will repeat this continuously. Everybody's okay so far? Okay, so now let's forget about the mathematical equations. What does this operation do? What does this operation do? If you want to describe it by words, what does this operation do?
Stretching.
Stretching it and
Flipping over.
And inserting zeros inside. Is this clear to everyone? Not only stretching it, because if you stretch it, this is still question mark, right? So now I'm stretching it and inserting zeros inside. That's what this operation does. So that's a good. Let's now answer the same question. If yx of n is periodic, the question is y2n periodic? It says what? Now the operation is stretching it, inserting zeros in the odd positions. If originally, if this is periodic, is this one periodic? Yes. Is everybody following why this is periodic?
What about if you had like every other one on here was on your x of n was the same,
Yes.
and then so eventually that when you look at y2 of n, it's just going to be a straight line, and it's no longer periodic.
Straight line is a periodic.
It's still okay. It's still periodic.
What is the definition of periodic signal? Once you shift it by a certain amount, you get the same signal.
Okay.
So a straight line is a
But a horizontal line or whatever, it doesn't have a fundamental period.
it doesn't have a fundamental, but it's periodic, right? This question is not asking you about fundamental period. Also, you're not going to get a straight line because I'm inserting zeros in the missing positions, right? I'm inserting zeros in the missing positions. So the answer is yes, it's periodic. Let's now look at the second question. So now I'm telling you that if I stretch it, inserting zero, the end result is periodic. Is the original one periodic? Is the question clear to everybody? The end result is what? Stretching it, whatever I have, I'm going to place it in the 2, 4, 5, 2, 4, 6, 8, inserting zeros in between. I'm telling you the end result is repeating itself. Is the original signal repeating itself?
Yeah.
Yes, very good. Why is repeating itself?
Because you're just removing the values that were zero and then you're just.
That's right. So basically, I'm not losing any values during this process. Previously, the odd positions are gone completely. But here, they are just placed in a different location, inserting zero. So if the new one is periodic, the old one is also periodic.
So that was the difference between the first question. The first question you know the values, so it could be anything, but this one you actually knew you're adding zeros.
You're adding zeros, right? This one says I'm adding zeros, so that's why it's periodic. Is everybody following the solution? So the key point is to understand what does the operation mean by these mathematical equations. Once you realize what it means, everything becomes easier. Do you want to sit in my chair? I have one more chair.
You're more than welcome to sit on here. I can stand.
I'm good. Okay.
Have I answered your question?
Yeah.